Okay, good morning everyone. I'll just review a couple of the problems you had on your activity for Hope McDougall online. This is due tonight, so if you do have any other questions, please join my WebEx or remain on the WebEx after class and I will entertain any questions you have. But I did want to go over a couple things that were on the assignment, a couple questions that students had. So I figure if they had a question, you probably have a question as well. The first thing is global maximum and global minimums, and local maximums and local minimums. Well, a global maximum or a global minimum is where no point on the graph is lower or higher than the global maximum or global minimum. So global max or global mins is where a point on the graph is the highest or the lowest. So let's take a look at this one here. So here I have my polynomial x squared times x plus 3 times x minus 3. And as you can see, it's a even degree. It's even degree 4. 2 plus 1 plus 1 is 4. It's degree 4. And it's positive, so it will be facing upwards. But notice here that this graph on the ends, the end behavior, it goes on forever. This point right here, we would call that a local maximum. It's local max. And it's not a global max because there's a point on the graph that is higher than that local max. Again, that graph goes on forever that way. So that would be a local max. But down here, there's no point on this graph that is lower than that point. Okay, so we would call this a global minimum. Okay, so that will be a global. Again, what is a global max or global min? It's where no point on the graph is lower or higher than the global max or minimum. Oh, and by the way here, I do want you to notice that because I have an x squared, or basically what amounts to two factors that are the same, x times x, okay, the graph will be tangent to the x-axis. Okay, the graph will be tangent to the x-axis. But for x plus 3 and x minus 3, my zeros are negative 3 and 3, it crosses the x-axis. Crosses. All right, let's look at another one here. So here, now I have the same graph, but now I have a negative leading coefficient. Okay, so I just flipped it over the x-axis. Again, it's still degree 4. It's still degree 4. 2 plus 1 is 4. But now it would be facing downwards. And it will go on forever in that direction. So notice here, so this will be a local minimum. So that would be a local minimum there. Okay, but notice here that this point, these would now be global maximums, okay, because there's no point on that graph that are higher than those points. So that will be a global max. Local minimum. Okay, a couple more examples here. So here I have x times x minus 3 times x plus 3. It's a degree 3 polynomial. It rises on the right and falls on the left because the leading coefficient is negative. But the graph goes on forever that way, and the graph goes on forever that way. And so here I would have a local max. It's not a global max because that graph, there's a point on that graph that is higher than that point because those y values are going up that way. So this would be a local max. And then this point here, this would be a local minimum. And again, it's not a global minimum because there's a point on that graph, actually an infinite number of points that are lower than that point. Okay, so I hope that helps in understanding global max and global mins and local max and local mins. And then one more here. Okay, so here, what degree do I have here? So 2, 1, and 1, that's degree 4. Okay, it's a positive leading coefficient, so it goes up on both ends. So notice right here, so that would be, so this would be a local max. Okay, because that graph, there's a point on that graph that is higher than that point, because that graph is going up that way forever. This here would be a local minimum. That would be a local minimum, because there's a point on the graph that is lower than that point, and that would be these points down here. But here, this would be a global minimum, because there's no point on that graph. There's no point on that graph that is lower than that point. Okay. I also want you to notice that we have x plus 1 squared. So we have two factors, x plus 1 times x plus 1. And anytime you have the same factor multiple times, it always touches the x-axis, is tangent to the x-axis. So you can see at the 0 of -1, it touches the x-axis. And then my other zeros are 1 and 2, and it crosses the x-axis there. Okay. Now, some questions that students had when they were entering this into Hope McDougall Online. All right. With this one here, you want to enter a quadratic function in intercept form for the given graph whose x-intercepts are integers. Assume that the constant factor a is either 1 or -1. Okay, so when I take a look at this here, I see my 0, so it's 1, 2, 3, 4. So my 0 here is -4, and this is -3. And this 0 is 0, and this 0 is 2. So my factors would be x plus 4, and then x plus 3, and then x minus 2. Okay, so the way you would type that in to verify your work, to check your work, is the way I did it. So that was x times x plus 4 times x plus 3 times x minus 2. Although I don't think it really mattered where you put that x at, but I put it out in front. Okay, so that's how you had to type that one in. And then the last one here, again, the same type of problem. Here I want you to notice that my 0 here is 0, 1, 2, 3, so this is -3 for that 0. And then this 0 is 2, but they're tangent to the x-axis. They're tangent to the x-axis. So for the 0 of -3, my factor intercept form would be x plus 3, but it would be squared. And then for my 0 of 2, it would be x minus 2, and it would be squared. Okay, and because the graph is facing downwards, it's even degree, but it's a sad graph, if you will. The ends are facing downward. The end behavior is going to -infinity. I need that negative out in front. So the way you would key that in, it was, as you see, they're negative times x plus 3 squared, and to get that squared key, you'd use that there. So you would enter in x plus 3, and then you would press that and enter in 2, and then you'd move your arrow over on the keyboard, and then you would enter in x minus 2 in parentheses, and then you would click that again to get your exponent, and then you check your work. Okay, if you ever need to back out because you didn't do something correctly, just press the delete key, the trash icon, and that would delete everything inside of there. Okay, so I hope that helps. So a couple of students had questions on that yesterday, so I figure if they had questions, so did you.